the subject compiler design. In this subject, previously we discussed about some of the concepts that is related to the syntax directed translation. Now, in this syntax directed translation, a main important topic that is called as intermediate source program. Intermediate forms of source programs. So this is the concept. Today we are going to discussion about this among this, and our outcome is understand and know the procedure how to implement this intermediate form of source programs is the current topic. Now here the intermediate code of source program is generated by the intermediate code generation phase. We know that there will be 6 phases of the compilation process, that is syntax analysis, semantic analysis, intermediate code generation, code optimization, code generation. That is previously first one is lexical analysis. Now the main aim of this one is to convert the given source program into which is in high level language. That means the programs are to be written in any of the languages such as C, C++, Java, etc. So that programs are to be translated into a understandable, that is a machine understandable code, which is called as object code. That's why it is also called as machine code. So compiler is the one which is the task carried out by the implementation of this conversion program to another. Conversion program means high level given program into a suitable. That is, suitable means the object code generation for the corresponding machine. So in this process, one of the phase which generates this intermediate form, that is called as intermediate code generation phase. So in this it represents an attractive form of trotted code, and then that is to be generated. And here the compiler is optimized after this phase and performs various optimization techniques on this intermediate code, and then finally produce the machine code and generation of this one. So this is the smoothness structure of the compiler, where the source code is to be evaluated clearly, and then machine understandable code is to be generated. So we know that analysis phase, synthesis phase, that means there will be 2 phases of the two parts while this translation of the compilation process. So here the analysis phase contains some phases, synthesis contains some of the phases. While implementing this analysis phase, automatically the output is to be generated, that is called as intermediate code. This intermediate code is to be passed to the synthesized phase of the analysis part and synthesis part. The output further process is given to synthesize, and the output of this one is this target code or object code, machine code, that is to be generated. Now in this process, what is the actual where it is to be? So we know that a parsing mechanism, syntax and semantic analyzer, static checker mechanisms, and then it goes to the intermediate code generation phase. After this, a code generation occurs. After this, the code generation occurs. Intermediate code generation. Now, the intermediate code generation up to this is called as analysis phase. This is called as analysis phase, and the remaining it is called as synthesis phase. From first phase to intermediate code generation, it is called as analysis phase, where it creates an intermediate code, whereas the remaining parts after intermediate code, that is code optimization, code generation, those two phases that comes under synthesis part, and this synthesis part can be delivered as the target, that is real object code. So we know that where it stands, intermediate code, that is to be stands in between analysis, that is output of this intermediate analysis phase is a intermediate code form, and the delivered output that is sent to where it is synthesized part. Now you know the position of the intermediate code, where it is located. So it is in between the after syntax and semantic analysis, intermediate code form are available, and then it is previous to the code optimization. So it is in between the two phases of the compilers. Now, if a compiler translate the corresponding source language to machine language without intermediate code, that means if you consider the phase is not available, then what happens? Then what happens means in this case, in this process, if the phase is not available, then the native compiler is required for each of the process. So in order to eliminate each of the machine requiring a native compilation, this we are going to eliminate. We are going to eliminate this process every time a new native compiler is giving is a hectic task. So that's why instead of removing and keeping getting each and every time a native compiler is a difficult task. That's why a phase has to be enhanced and implemented to get rid of the task, that is called as every time a new compiler is to be getting with the unique machine by keeping analysis portion is same for all compilers. We are going to keep analysis machine for all compilers. So it is a elimination of this hectic button. Another one is synthesized part. We know that previously we have seen analysis part and synthesized part. Here synthesis part is different. It will be different for that particular machine. So a new code is to be generated according to the needs of that particular machine. That particular program requirements, that particular setup for the corresponding machine, a new code has to be generated so that it need not go to a native compiler. So that reduces the burden of the task of the user. So it becomes very easy to generate an object code from the source code, and performance are also get code performance improved, and optimization techniques are also you can implement further. So there will be lot of scope is there if you implement in order to implement this type of this process. So the main task is we are going to separate analysis and synthesize part. Why? Because of this intermediate form code. If intermediate code generation phase is not available, then a separate machine, unique machine is to be kept for each of the compilation process, and then that is to be there is no separation of the phases are required. So by keeping separation and instead of reducing that task, we are going to implement this intermediate code generation and makes the code performance simpler. Now in this this model, that is the two parts, analysis part and synthesis part, the two parts of a compiler can be described as the first part, that is, for example, here analysis is the part 1 and the second part is synthesis is the second part. That means some of the phases, first 4 pages comes under analysis part and remaining 2 phases comes under synthesis part. That means whatever the code that is generated by this analysis phase comes to the given input to the synthesis part, and synthesis part accepts that input and then generates an output code that is to be generated for this. So here we can say that the front end of the compiler, this is called as front end of the compilation process, and the synthesize is, we can consider it as a back end of the compiler. Why? Because the front end of a compiler translates source program, that is the given program, into an intermediate code. That code is an independent or intermediate code. That code is independent intermediate code, and this code is to be taken by synthesized part of the compilation, that is back end of the compiler, and uses this independent intermediate code that generates a target code. Here are 2 things. One is analysis part, synthesized part, and the output that is to be generated by this is to be considered as this as intermediate code. That code is independent intermediate code, and this code is accepted, passed to the further phase of the compilation process and delivers node code that is called as object code, target code, which is easily understandable, executable by the machine and getting the results. So what is the advantage of this separating this analysis part and synthesis and the separation of front end as well as back end? Now in this, the first advantage one is here machine independent intermediate code. One of the major one is machine independent intermediate code will be that is carried out the task of portability. That means the program with that portability enhancement feature. Portability enhancement, that is one of the main advantages. And the second most is source code modifications. Source code modifications is to be improved by optimizing the intermediate code. Optimizing the intermediate code, we can improve that is performance of the source code. There will be several techniques. We will discuss about the techniques where the optimization can be improved. Based on that, the code performance are also improved. So for that reason also, we can use this type of machine independent code generation feature in case of analysis phase where intermediate form is to be developed. So in this way, it will be very lot of advantages are there to separate the phases and get the object code makes simpler and portability also achieved with this concept. With the diagram notation, we will see the phases. Lexical analysis is the first phase of the compilation process. Second phase, syntax analysis. And third phase is semantic analysis phase. Fourth phase is the intermediate code generation. Fifth phase is code optimization. And the sixth phase is target code generation. Now there are total 6 different phases of the compilation. 6 different phases of compilation process. So these are called as phases of a compiler. Simply we can call as phases of a compiler. We can say that this is the phases of the compiler. Now what is front end? It is what is the code that is generated by front end. Now we have taken previously 2 parts. One is analysis part and second one is synthesize part. Now front end accept the source code, generate it accepting the source code that is from the given language, and following the 4 pages releases this analysis phase from the front end that is called as machine dependent code. So that code is to be passed to the second phase, that is next part, synthesized part, which is called as backend, and here machine dependent code is to be generated. Where the code that is generated is here machine independent code is generated. Now if you generate machine code directly, that means instead of not keeping intermediate code generation, machine dependent code only we are going to generate directly from the source code. Then what happens? So here independent code is not available, then there is a problem of portability enhancement feature. So instead of reducing the task of the compilation process or burden to the user, or what happens, we have to require one more compiler, one more optimized technique, that is a target machine is required with a one setup procedure where optimizations are required and code generators are required, and machine independent code is missed. So that is to be required for that optimization process. And then here again bytecode problem, language specification problems will occur, and language dependent feature 3 underscore generations. So here intermediate code is to be developed with the machine independent feature in analysis part, and the same code is transferred to the backend and develops a machine dependent code. So this intermediate code has a lot of advantages. Why? Because a language specific feature is to be developed with this, and this contains a bytecode information for Java language, and language independent features which are available in the 3 underscore notations, and then optimization process occurs. Like that, the sequence of each and every operations comes into picture, where the portability enhancement is to be carried out successfully without having this without without introducing this intermediate code generation. It is not possible to carry out the mission dependent code directly. So that's why this phase is required compulsory in order to achieve the task of mission independent feature portability, independent features, mission code generations. This phase is compulsory required. What is this one? Intermediate code generation, where a 3 address code is to be written clearly, and this code carries out the task of bytecode information for language such as Java, and language independent features, and all this to be taken care of this particular phase. Now we will see how the next coming sessions we'll see what is meant by a 3 underscore notation, and what are the different types of 3 address statements, and conversion syntax directed translation of each of the statements. We are going to give a brief discussion about that one in the next coming sessions. Now in this intermediate code, there will be a lot of advantages, and based on that we'll move into the this intermediate representations. Without that one, there will be several problems arises, and the task is not completed, and reduce the burden to the computing system. So that's why it is placing an important role. Now, what is an intermediate code? What it can now here until now we have seen whether it is required this phase or really or not, and what are the advantages, what is the pros and cons we have seen previously. Now, what are the notations used for the procedure describing the intermediate code? So, what exactly inside this phase? What are the terminologies? What procedures it is to be used? So, generally, the representations used in this intermediate code are: one is polish notation, Polish notation. We know that these notations are used in tree structure notation. That is, we will see this one how. And second one is syntax tree notation. This syntax tree notations previously also we have discussed about this topic. We will review. And another one is most important one is three address code representation. The most important one is three address code. In this three address code, there are three types. First one is quadruple, second one is triple, and third one is indirect triples. Now here first notation representation, how it can be implemented as a polynomial. Now we know that what are the different ways of representing these notations. So for example, infix notation. There are three notations are there to describe the structures. One is prefix notation, another one is postfix notation. So this infix notation is described as the operand followed by operator and followed by operand. Whereas prefix notation, that is to be described as operator followed by operand and then operand. And the postfix notation is to be represented as operand, another operand followed by. Now in this the prefix notation, it is also called as Polish notation. So this Polish notation, see here, the Polish notation, the first round, that is the notation that is to be described in the form of intermediate code. This is called as prefix notation. That means where these operators are to be appeared at the beginning, later operates. That means here in the prefix Polish notation plus AB, indicating that the expression contains operators at the beginning and follows the operator. That means operands following these operators. Operand follow. Whereas in this one, postfix notation, operator following operands. So plus AB plus. Now here what is the notation? Here postfix notation, operator followed by operand. A and B are the operands. Whereas in this one, infix, it contains operators in between the operands. So this is called as infix notation. Now we will have the notation that is Polish notation, that is also called as prefix notation, where the operators appears at the beginning before the operands. That means operands follows the operators. So these are the notations which are used for the implementation of this structuring things, structure notations. And the second one is abstract syntax trees. See here, abstract syntax trees indicates that it is a parse tree structure and one of the intermediate form of the source code. And here this tree structure is suitable for intermediate for optimization of compilers. So optimization procedures are to be easily implemented where intermediate form of source code is available. So for that, a parse tree structure is to be required. So for that construction, this intermediate code also helpful. Now, what is the parse tree? We discussed in the previous sessions. And now in this unnecessary information, that means what is the required, that is to be exactly specified for each of the branch of the trees. Remaining that implementation is not required to show that one. So here efficient representation of the source program, that is to be transformed as a parse tree structure, then that is called as abstract syntax tree. That means parse tree notation, representation, abstract syntax tree, abstract syntax tree notation. Parse and abstract. That means skipping off unnecessary information to produce the efficient representation of source program. In parse, suppose for example in parse tree there will be lots of information. It will contain several information, several things, attributes, variables, operators, numerals, etc. So all this information is really required or not is to be verified, and from this you have to carry out necessary and sufficient information which are really required to compute the expressions, which are really required to compute. So from this you have to write the attributes or constants or variables which are necessary and efficient. So this requires this transformation of parse tree. So we have constructed the tree structure, and once again we are transformed into another structure. Here we are going to transform into another structure. That structure representation is called as abstract syntax tree. But here it doesn't contains the all the informations, but only the computational requires information only is to be present for this one. So that is the main important relevant description about the abstract syntax tree. So in order to produce the source program, object program from the source program, we have to implement a necessary and important step that is called as intermediate form of the source code. These intermediate forms are to be very useful and based on this construction of parse tree with the relevant information. Again, that information also to be skipped some of the contents and given efficient. That is to be called as abstract syntax trees. Abstract syntax trees. Now, these syntax trees are also called abstract syntax tree. But because the first point is, it is abstract representation of parse information. That means, already told that the efficient information, efficiently and necessary information which is required for that is to be produced available, what is required, that is called as abstract representation. That is called as abstract representation. Here in this one, doesn't provide all the characteristics. That means some of the things may be missed out. Some of the things may be missing. That means it doesn't affect even if it doesn't affect the corresponding parse tree notations or abstract tree syntax notation. So some of the information is to be compulsory, is to be lost, but that doesn't mean. So here no rule codes, no parentheses, so that type of information are to be skipped off. It doesn't required into this structure. So that structure is called as abstract syntax trees. And contains least unnecessary, only required information only, doesn't produce unnecessary, and only required information only it is to be shown. And more compact. So we have seen previously also differences. More compact in the sense the information which is actual required information only to be kept compared to the parse tree structure. Parse tree structure where relevant information or irrelevant which is required or not we cannot see. All the contents are to be available with this structure. All the contents, that is we can easily show, but that is less compact. Whereas here more compact, that means that is packed with the only necessary and sufficient information. Only the necessary. That is the how we are getting these syntax trees are also called as abstract syntax tree, where information is to be passed from parse tree to abstract syntax tree, only the sufficient and required information only. Coming to the three address code notation, what is the code? This is the form of the code which is used inside mainly intermediate code generation. This intermediate code generation mainly uses this code that is called as three address code node procedures. This procedure contains some references, that is operands and results. So how many references here? It doesn't holds it contains maximum three references only. Max three references only. Not more than three references are not allowed in case of three address code procedure representations. And only out of these three max, two is used for the computation purpose and one reference is used for the result. Only one is used for the result procedure, result run, and two is used for the computational purpose. That means here out of the two, we can give, it may contains 0, 1 or 2 also. It may contains of the two, either 0, 1 or 2. So, but here the computation, one is out of that max 3, one is really required. One is at least one reference is max 3 out of one reference is compulsory required. So that is known as three address code computation. For example, if you see this computation, if you see the computation, that is x equal to y op z, x equal to y op z. In this computation, what is the x is one reference, that is this is the address reference, and that is y is one more address reference and z is one more address reference. So we get three references. How many? Three references we are getting. Three. Sometimes it contains less than three also. But in this computation, in this statement, we are getting three references. Sometimes it may get less than three also, but still it is to be considered as a three address statement only. But out of that three address, it cannot contain four. That means more 4 is not allowed. Above 4, greater than 4, greater than or equal to 4. Those references are not allowed. That means if at all, if that computation contains more than, suppose if this type of computation x equal to y op z op some p, sometimes this comes, so op q's for example. So this is one object, this is one object, this is one object, and this. So how many? 1, 2, 3, 4. So if 4 references are there, this is not a 3 address code. Then this is not a 3 address code reference. Suppose if it is not a 3 address code reference, then we have to make sure that once again using other temporaries and convert into a 3 address code procedure and limit. So that we will discuss in the next session how it can be translated into a 3 address code notation by using temporaries. First, initially 3 address references code, 3 address code which contains max references are 3. So in this example also contains 3, and out of that it requires at least one, at most one operator. At most one operator is required, that is on the right hand side of the instruction. So here, for example, if you take this one, this is an operator. This is an operator which is available on the right hand side of the expression, right hand side of this instruction. Right hand side of this instruction, it requires at least one operator. Maybe more than one also may require. That means it may contain more than one also. That means 2 operators, 3 operators, like this. That is also allowed. But at most one is required for this computation. That means whether it comes under a valid 3 address code notation or not. Verify whether it contains at least one. Then we can say that yes, it is 3 address code. Suppose it doesn't contain any of the 3 operator, that means for that instruction, then we can say that it is not a valid 3 address code notation. So based on that, the arithmetic operations and expressions that is to be allowed and computed based on this. So it is the form of a tree intermediate code procedure notation. So why it is means based on this, we can get an advantage of compilers optimization procedures. It is the further fifth phase of the compilation. We will see shortly what is this optimization, and also either the expression which contains further more operators and operands with the with computing. That means more object references are there. Then we can actually separate and make into a 3 address code notation, and then it can be translated into the corresponding assembly language program notation. That means it is very easy if at all if the program, if the particular statement which does not describe the property of 3 address code, then that can be converted or translated and generated a 3 address code notation by implementing, that is breaking down into separate instructions. A separate instruction is to be generated from the large expression. Say for that computation, a single computation, we are going to make that unique computation into 2 more computations, so that the task of the 3 address code procedure is very further simplified. And another one is, we know that 3 address code which contains carries 3 operands and at most one operator. That means 3 max at least required, and at most one operator on the right hand side of the expression instruction is required. So this is the form which is used, x equal to y opz. This is the actual form. After that, maybe y missed it or z may not be required, but op is at least 1 is required, and x is at least 1 required. So at least one reference, this out of x, y, z, at least one of the reference may be holds good if any of them is not required. Out of these operators, at least at most one operator that is to be required in order to carry out the task of the 3 address code. So this is, in that way we are going to see how this, through an example notation, how the task of the 3 address code notation. So here the given expression is to be not in the 3 address code notation. Why? Because here this is an operator, this is operator, this is, so 3 operators are there. And object references, how many are there? That is A, B, C, D. So 4 objects. So 4 address references are there and 3 operators are required. But according to the constraint of this 3 address code, at least it require one operator, and one operator is required, and at most one object reference is required. Max. More than, that is here, more than 3, that is previous also we discussed about 3 operands and 1 operator. 3 operators and 1. But here what is the operators? 3 references and 1 operator. But here instead of 3, how many? 4 are there. But here it is. So in order to do that task, to initially break down into task into several further small instruction. For example, if you take B star C, this is to be computed initially with a temporary variable, say T1. Temporary variable, say T1. So that's why here we assigned T1 equal to B star C. So that is the expression initially we have taken, T1 equal to B star C. Now what is, you can take A plus T1 plus D. Now this portion you can complete with one more task, that is another new temporary, say new temporary T2. Now T2 plus D. So T2 plus D will get one more temporary, that is assigned T3. Now T3 equal to finally T2 plus D. Now T3, T2. What is T2 here? If we say T3 equal to T2 plus D, T2 equal to A plus T1. Now already D is available. Now what is T1? A plus T1. T1 equal to B star C. So what is the final expression? A equal, that is A plus B star C plus T. But we are going to break down each of the expression into a simple notations by using the temporaries. So what is the advantage here? You see the from description about this procedure of 3 underscore. It contains one operator, and T, B, C are the object references in this one operator, and references are T3A and T1. And here this is the operator, and object references are T3, T2, and so max at least one, at most one operator and three object reference. So these by using these references, we can say that the valid 3 address code statement. That means a single statement is to be breakdown into further breakdown into a 3 address code procedure, which is following 3 different statements, and each of the following with the different tasks. So that's why this is very important and useful procedure for the implementation of 3 address code inside this intermediate code generation phase. So this is actually an important requirement phase, and that is how we are going to implement. As you can see in the next further sessions, how this will be generated with this intermediate code, as that is syntax directory centralization procedures. Now with this, all these contents are available in the book, that is Compilers, Principles and Techniques, that is Alfred Ullman Sethi. Now as the time permits, then here we are going to stop the session. Next coming session, we are going to give a brief notation about the syntax directed translation schemes for the bullet expressions, and how the 3 address code types that is to be implemented in the form inside the intermediate code generation phase. Okay, thank you all of you. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.